heart. Still, graphene-based electrode gives you better results. But why we are looking at the ear-based is because when you want to do a continuous monitoring or when you want to do a quick monitoring, you can do ear without taking a shirts off, right? So it's more convenient for the people. So we are interested to measure somewhere behind the ear and see whether we can improve the signal. The signal is there, of course, from the heart, but as the signal travels further from the heart, it's deteriorate very fast. So graphene improves it, but is it enough? We don't know yet. So we want to make further advancements. Next slide, please. So these are results in summary. So signal to noise ratio is a ratio between the maximum peak to where the line has to be flat. So if the line in between the peaks are flat, that means signal ratio is infinity, right? Because the signal divides by the zero. But because there's some signal coming off from where the flat line is, so signal to noise ratio is never going to be flat, never going to be zero, infinity. So, but what you can see is the graphene-based has got slightly better, 27.03 when a chest, and the other one is 25.21. So this is I think this is a used logarithmic scale. So the linear scale may be slightly different, and you don't see big difference in the calculation. Yeah, I think there's a when it's a covariant type, ambu is larger, covariant is smaller. The 25.32 and 21.21. Still, graphene base is bigger, slightly improved, and you can see ear based when it's a ear lead, second column, yeah, the second row, that is the signal ratio has gone down, but again, graphene based one is better, much better. So we can conclude that the graphene has improved the signal to noise ratio, have improved the electrode property. But is it enough? We don't know. We need to still work on that. Next slide, please. Right. So that's what about electrode at the moment. So I'm going to touch on some sports or wearable sensors, right? So when you talk about sports and wearable, there are basically 3 or 4 sensors people are using in a daily life. People use for the fitness purpose, which is accelerometer, gyroscope. You can see the table there. Right? The first column, what wearable is a Fitbit, Nintendo, and on different PlayStation, blah, blah, blah. And the second column tells you accelerometer.